Good morning. Now we have to see about the internal test answer key for part B and part C part. So first we have to discuss started with set A question. Here the first question is for 8 marks, that is state and prove divergence theorem for coordinate system. So already we know the statement, that is divergence theorem relates your volume integral with surface integral. Mainly that is the application of your divergence theorem, and here the divergence theorem is nothing but volume integral of your del dot A dv is equal to surface integral of A dot ds. So now we have to prove that. So for giving the proof, we have started with the Cartesian coordinate system. Assume a vector A in Cartesian coordinate system with its ordinates, and next we have to prove with divergence of vector A. So for divergence we have to take a dot product of that vector with differential vector. So del dot A is now given by dou Ax by dou x plus dou Ay plus dou y dou Az by dou z. So now we have to take the volume integral on both sides of this equation. So from the volume integral, your dv is equal to dx dy dz. So now we have to take the part 1 in the left hand side, that is only the volume integral of dou Ax by dou x into dv. So in that, if we have dx and dx, it is get cancelled. So now it is dou Ax dy dz. So when we take the integral, it gives the answer as Ax dy dz. Now it is nothing but your surface integral of Ax along dsx direction. So now your del dot A dv is equal to Ax dsx, Ay ds7 plus surface integral of Az dz. So as a whole, it can be written as surface integral of A dot ds. Thus your left hand side will be equal to right hand side, and it is proved. Your divergence theorem is proved. So next we have to go with the question 7. So here your question 9. The question 9 is to find the electric field intensity for a uniformly charged circular disk with rho s. So here your surface charge density is given as rho s, and you have to find out the electric field intensity at F point. So for that you have to make the assumptions that the radius of the disk is r, and the point P is the at the height h, which is on the axis, and ds is the small elemental surface area which is at a distance small r. So the total surface area is for a circle is given by pi r squared, and for ds you have written as 2 pi r dr. Differentiate that. By Coulomb's law, we can write the electric field intensity as q by 4 pi epsilon r squared. So here q is nothing but surface charge density into area, that is rho s into ds, and 4 pi epsilon d squared. So from the figure you have to substitute the values for d squared and ds. So from the ds you have to write the value of r dr. So substitute every value from the figure and got the equation as d is equal to rho s 2 pi epsilon sin theta d theta. So here we have only consider the vertical components only, since all the horizontal components are cancelled each other. So that only we have considered the cos theta. So the rho s to epsilon 1 minus cos alpha will be your answer for this derivation. So next one, to determine the electric field intensity and potential between two concentric spherical cells. So if the two cells are concentric, the center will be C. So first we have assumed that the charges are separate, that is q1 and q2. So by applying Gauss law, surface integral of d dot ds equal to q. So here inside the cell there will be no charge. So when r is less than a, electric field intensity will be 0. When r is equal to a, then there will be a charge of q1, that is epsilon e dot surface integral of d dot ds equal to q. D is nothing but epsilon e, and surface area, total surface area for a sphere is 4 pi r squared. So that epsilon e 4 pi r squared q1. So here e can be written as q1 by 4 pi epsilon r squared. So when your radius is equal to a, q1 by 4 pi epsilon a squared. When your radius is in between a and b, only the charge q1 is enclosed, so the equation is q1 by 4 pi epsilon r squared only. For radius is equal to b, the total charge enclosed will be q1 plus q2, so the electric field intensity is find out of q1 plus q2 by 4 pi epsilon b squared. For radius greater than b, your electric field intensity is q1 plus q2 by 4 pi epsilon r squared. So you have to draw the graph for electric field intensity for various radius and then find out the potential. The potential between two concentric spherical cells, we have assumed that q1 and q2 is equal to q and b is equal to line integral of minus d e dot dr. Substitute the value of e and integrate. So from the integration we can given as b is equal to q by 4 pi epsilon 1 by a minus 1 by b. So in case the charges are different, then the equation will be q1 by 4 pi epsilon a1 minus q2 by 4 pi epsilon b. Thank you.